We've already learned about data structures. In a previous video, we learned about lists. Lists are something that can hold data and store it, and you can modify and manage your data. That's a data structure. Today we're going to learn about three others, and one that you already actually know about. But before we do that, I need to talk about what's called mutation or mutability. And what that means is basically just the ability to change something. So you may have heard of the Teenage Mutant Ninja Turtles or X-Men mutants, and what those are just they're the turtles were something that had changed from something else into these ninja turtles, and then mutants in X-Men were normal people that had somehow changed into something that had extra ability. So it's just basically it's something that's changed from one thing to another thing, or the ability to change. And in programming, we do this all the time. We've already experienced mutation, but today we're going to learn about immutability. So the lacking the ability to change. And so an example of that is a string. And you may be thinking, I already know what a string is. A string is a data type. It's not a data structure. And in a way, you're right, because languages nowadays make strings feel like data types, but really they're just lists of characters. That's all they are. Underneath the covers, that's really how they're implemented. And so we can demonstrate that by creating one. So we'll have Meister, and that will equal hello. And then we will try to just print out an element of that, like we do with lists. So let's try printing out the second element with the index of 1, as we remember from before. And now let's run that program. And it'll give me an E. So you can see that a string really is just a list of characters. But the trick is that we can't actually change what is in it. So I couldn't make this an I. And you're going to see that it yells at me. It's going to say, hey, the string object does not support item assignment. That's because it's immutable. So that's really something interesting, is that a string is really just a list of characters, but it's an immutable list of characters. And so the same thing goes with what's called a tuple. So let's create a tuple here. And what's really a tuple is really just a list, but instead of doing, and when we create one, instead of doing brackets, square brackets like that, I'm going to use parentheses. And let's do the same thing. Let's try to print out an element. Let's print out the second element again. Oops. And you can see that it gives me a 2. So really a tuple behaves just like a list, like we've seen. But the same thing happens when we try to assign things to it. So if I try to do 4 here, it's going to yell at me saying tuple object does not support item assignment, because it also is immutable. So if it's immutable and you can't change it, what is it good for? Lists are mutable. You can change lists. Doesn't that seem better? It seems like it has more capability than a tuple. But the reason that, so it's actually kind of interesting, is that you don't actually always want to change something. The ability to change something can get you in trouble, because if you had a large program, and when you have a large program, sometimes you lose track of things. So in one part of your program that is way over in one spot, you may create a list, and then that list may travel. You may give it to various things in your program until eventually it's on the other side of your program. Just if we were going to spatially think about a program, that list may have traveled a long ways through a lot of different parts of your program, and now this piece is saying, oh, I got a list. Let me just use that list and change something in it. Well, this part of your program doesn't know anything about the other part, and so it shouldn't really be changing this list, because it doesn't know anything really about this list. It didn't know how to create it. It might not know what it's for, and so you don't want to actually give that part of your program the ability to change elements in that list. So maybe you give it a tuple. Also, you often have to convert between tuples and lists and tuples when you give things to modules. So the way that you can do that is by, let me just show you how we can transition here. So you can, first I'm gonna be able to print out the type so that we can see that here. But the way that we do it is we specify the tuple we want to transition, and then we can use a built-in function called list. So the way that this goes is this first part's just going to print out the type, but we transition your tuple into a list with this part of the program. So let's try doing that. So now it's telling me, hey, yeah, that's a list. But if I wanted to do a list into a tuple, which is the more common thing that you'll have to do if you're going to be transitioning or giving it to a module, let's do that. And then let's just change this. We want to change it to a tuple. And there you go. So that's how you can transition between lists and tuples, and that's something that you'll need to know if you're going to be giving them to modules. The next thing we're going to learn about is dictionaries. Dictionaries are basically, so if you think about a dictionary, and this is something that is kind of getting out of fashion because nobody has like a book dictionary anymore. You just look it up online. But a dictionary essentially just has a definition or the word that you're going to look up, and then it's got its definition. Sorry. It's got the word that you want to look up, and then as a value, it's got its definition. So that's what a dictionary is. And the same thing applies in programming. So if we've got my dict and we want to apply that with some values, we can create it with values by specifying curly braces. So lists have square brackets, tuples have parentheses, and dictionaries have curly braces. So first thing you do is you want to give it a key, and this is going to be just with a value of the string 1, and then a colon, and then its value. And you can give it more than one by separating them with commas. Then if we want to print out an element in the dictionary, then we just specify it with a key. So instead of doing like with lists, you specify a number here because you wanted to get an index. Well, dictionaries aren't indexed. You can't find it by putting a number in there. You have to put one of the keys. That's how it's going to find the items in the dictionary. So if we wanted to print out that element, then it'll give me the value. So you specify the key and it returns the value. So that's how you can create and access elements. But what if we tried to do something like, well, let's say that we wanted to get the element with a key of 4. So that's not in our dictionary. So what's going to happen? Well, it's going to yell at us. It's going to say, hey, that key is not in the dictionary. So if I try to print something after, do you think we're going to see here? Well, the answer is no. So whenever you encounter an error, this is something that we talked about a little bit before, and we'll talk more about later. Whenever you encounter an error, if you don't recover from it, it's going to ruin your program. It's going to just shut down your program. So to be careful, it's really important that you try to avoid these in general by doing if 4 is in my dict, okay, now what's going to happen? Oh, there we go. Now it prints here. And it's because 4 is not in the dictionary. So we were able to check to see if it was in the dictionary before we tried to get it out. So before we encountered a possible error, you should probably check to see if it's in there. So that's just a really important practice. Then the final thing, or the last two things that we want to be able to do is sometimes we want to be able to add. So we could say if 4 is not in the dictionary, then let's actually add it. And let's get rid of this print. So let's add it to the dictionary, and then let's see what's in the dictionary after that. So now we've got the element 4, the key of 4 with a value of the number 4. But let's say that we wanted to actually delete the second element. So we could do my dictionary with a value of 2. And let's spell it right. And let's see what happens when we try to delete it. Well, there we go. 2 is gone. So those are the basic elements of a dictionary. You can create them, check to see if things are in them. You can add things and delete things. So we use these all the time. You can also iterate over them, and that's something that we're going to learn about when we learn about loops, but not right now. So these are the basic data structures: lists, strings, tuples, and dictionaries. We use these all the time, so it's important to know what they are and how to use them.